Hi girls. Okay, so the next one then is number 11, and this is volumes of gases, so this is number 11. Now we would have done a little bit on volume of gases under the gas laws, but we definitely had a little bit more left to take a look at. We've done a couple of these type of questions down through the years as we met them, but there's a little section in your book in chapter 11, which is on stoichiometry, which is on this, and there's a good few examples in your book of it as well. So I'd ask you to take a look. It's the last section of chapter 11. It's calculating volumes of gases from balanced chemical equations. So in your textbook, it's page 146, and it runs all the way to 148, and he's got a good few examples in that one that's going to be similar to what I'm doing today. So if you're still struggling with it, I'd suggest you start there and take a look at it first. I'm going to assign you a couple of pieces of work, and then we'll see where you're going from, or if we need to do a few more of these. It comes up very rarely, and it's normally question 11, and therefore it's the one that I just put off, because it's a calculation that some of you will get easy and you'll be like, I don't know what our problem is, this is no harder than anything else. And for others it's very conceptually challenging, because it is a gas, it's something you can't see, touch or feel, and there are experiments that you couldn't do, so that makes it a little bit more challenging. Okay, and when you're conscious of that, it makes it a little bit easier going into the question. So it's not something that everybody's going to have to get, but it's definitely something we have to cover. Okay, so we're looking again, as I said, example 11 on the sheet. So sulfur dioxide emissions from waste gases are reduced using calcium carbonate. So you're starting with calcium carbonate. What volume of sulfur dioxide measured at STP could be removed from waste gases using 1.5 kilogram of calcium carbonate? So you're starting with 1.5 kg of this, and it's asking you are reduced using SO2. So you're looking at the conversion between it and SO2. So you've got your calcium carbonate and you're taking your SO2 out of the system. It'll also require oxygen, and you'll be making calcium sulfate and CO2. And you're probably saying to yourself, well, how was I supposed to know that? And the thing is, you really aren't supposed to know that. And normally if I was in school with you, I'd have given you the formula before you go home, because the formula of that magnitude would always be given to you in the exams. So a formula that something like this, where you're taking away SO2, there is, in fuels and heats of reactions, we do talk about removing SO2 using what are they called in the backs of cars that remove exhaust fumes. We talk about scrubbing SO2 out that way, but we don't give you any formulas for it. And in the exams, they certainly would give you the formulas. Any of the exam questions you take a look at, they all have formulas assigned to them. Okay, so that's the formula we're starting with. We've been told we're 1.5 kg, and we're asked to see how much of sulfur dioxide I could take out of the system using this formula across the line. Okay, so the first thing I suppose we have to take a look at is, do we know what STP is? So STP is standard temperature and pressure. So we're trying to figure out, we're asked what volume we'd have. So 1 mole at STP is 22.4 litres. And that's always given to you on the front page of your paper. They don't have to ask for STP. They could ask for room temperature, at which point 1 mole is worth 24 litres. But they will tell you which one they want you to use. And they will tell you at the front of your page whether it be 22.4 or 24. Okay. So we're starting off, and before I start, we're going to just take a look at the ratio that we're dealing with. And the ratio, I'm just trying to grab a different colour pen so it might come out a little bit easier. Here, so the ratio that we're dealing with is 2 moles to 1 mole. And there's a ratio keeps going, so I could say it's 2 is to 1 is to 1 is to 2 is to 2. But these are the two things that I'm working with. So I don't really care about the other ratios in this particular question. To be able to use a ratio, I need to have it, instead of in grams, I need to have it in moles. So that's my starting point. So 1 mole of CaCO3 is equal to 100 grams. I didn't have 100 grams, so it's 1 gram is 1 divided by 100. I had 1500 grams. So 1.5 kilo is 1500 grams. 1 over 100 multiplied by 1500. So I had 15 moles of CaCO3. Okay. And that's equal to 2 parts of my ratio. So I want to know what 1 part is because I'm looking to work out the volume of SO2. So the first thing I'm going to have to do is halve that, or divide it by 2. So it's 15 moles divided by 2, and this is because of the ratio. So this is all because of the ratio that we've got at the beginning of the question. So that means I had 7.5 moles of SO2 that could be taken out of the system. And the question asked me to find the volume at STP. So I know that 1 mole is equal to 22.4 litres, and I had 7.5 moles, so it's 7.5 multiplied by 22.4, and that comes out as 168 litres of SO2. Okay. The starting point for this question will be take the balanced equation and start with the moles. To decide whether your STP or room temperature will be your next step, and then to convert whatever grams you've been given to moles and apply your ratio. Okay, and you can see now, girls, why this ratio gets used quite a bit across your course, and that's really where question 1 has changed. That's why they've changed question 1, because question 1, you using V1, M1, N1 never allowed you to really see that you were using the ratio there, even though you were using the ratio, because that's what the N values did, the N1s and N2s. But because you were subbing into a formula, it became about subbing into the formula rather than about the ratio. So if you wonder why they changed question 1, and you probably don't, but that's why. Okay, because this ratio then, if you really understand your ratio, it applies to gas laws, it applies to water of crystallization, it applies to all of your volumetric analysis, and it applies to pretty much 99% of the calculations that you've got. Percentage yield, all of those are also all based on ratio. Okay. So the last little part then is to give you some a piece of work on it. So we'll start with page 150, and I'll ask you to take a look at question 11.14, 11.15 and 11.16. And then when I have a look at them, if they're correct, perfect, we'll move on. And if they're not correct, then I'll go and we'll have to find a couple of more questions, maybe from the exam papers, etc. And take a look at those for you. Okay, so that's water of crystallization and volume of gases. We're getting down through them. A couple of them are very straightforward. So when you get to parts per million, volume per volume, etc., they're going to be much quicker on the next page. But these ones take a little bit of time. You just have to have a bit of patience with yourselves. Okay, I'll talk to you later. Take care. Bye.